Emergency agencies quietly shifted their internal protocols, treating Campi Flegrei and Vesuvius as a single interacting hazard rather than two isolated systems. Thermal imaging now shows the underground pathway slowly widening as pressurized vapor fractures additional bedrock. Each steam release is followed by new seismic bursts, indicating the conduit is still evolving. If this corridor continues to grow, a critical question emerges. Could failure in one volcanic system trigger instability in the other? And if so, how do you evacuate a region with more than 3 million people facing a dual volcanic threat? Campi Flegrei sits just west of Naples, one of the most complex volcanic systems on Earth. The caldera spans roughly 8 miles and represents 600,000 years of repeated catastrophic eruptions. Its destructive potential is not theoretical. It is written into the geology of southern Italy. 2 eruptions define its legacy. 39,000 years ago, the Campanian ignimbrite eruption expelled more than 200 cubic kilometers of volcanic material. Ash blanketed much of Eastern Europe. Global temperatures dropped. Ecosystems collapsed. Some researchers believe the eruption may have contributed to the decline of early human populations across the continent. 15,000 years later, Campi Flegrei erupted again. The Neapolitan yellow tuff explosion released another massive volume of material, further hollowing out the caldera that now sits beneath modern Naples. According to Dr. Giuseppe Mastrolorenzo of the INGV Vesuvius Observatory, Campi Flegrei is fundamentally different from a typical volcano. Instead of a single magma chamber, it contains multiple reservoirs at depths between 3 and 8 kilometers, connected by a fragile web of conduits. Pressure changes in one part of the system can destabilize the entire structure. This interconnected architecture is what makes the caldera so dangerous. Historical records show a repeating pattern of unrest. First comes bradysism, the slow lifting of the ground as magma and superheated fluids rise. In Pozzuoli, this has been documented for centuries. Ancient Roman buildings now sit partially submerged because the land beneath them rose and fell over time. Next comes seismic unrest. As pressure builds, the crust fractures. During the 1982 to 1984 crisis, more than 16,000 earthquakes struck the region, forcing evacuations and damaging infrastructure. Then gas emissions intensify. Fumaroles release carbon dioxide and sulfur dioxide in increasing concentrations. The air becomes corrosive, sometimes deadly in enclosed spaces. Finally, thermal anomalies appear. Ground temperatures spike in isolated zones. In past episodes, surface temperatures became hot enough to boil water and scorch soil, clear evidence that magma was approaching the surface. Satellite data shows that since 1950, Campi Flegrei has uplifted more than 4 meters. Today, the rate has accelerated to roughly 2 centimeters per month, more than triple previous unrest phases. But the events of March 2025 exceeded all expectations. On March 13th, a magnitude 4.4 earthquake struck the caldera, the strongest in decades. What followed was more alarming. Using advanced AI-based seismic analysis, researchers identified over 54,000 micro-earthquakes triggered by the event most too small for traditional monitoring systems to detect. The data revealed something unprecedented. The quake had activated Campi Flegrei's ring faults, the circular fracture system that defines the caldera's boundary. These faults, largely dormant for centuries, were suddenly releasing energy again. Even more concerning, the seismic signals converged downward into a newly opened conduit extending deep into the crust. That conduit was transmitting pressure waves toward Mount Vesuvius. Dr. Tatiana Veniero of Stanford Earth Sciences explained the implications clearly. When a geothermal system is sealed, pressure remains contained. When that seal fractures, fluids migrate. And when fluids migrate through connected systems, instability spreads. Within 2 days, monitoring stations recorded temperature increases of more than 12 degrees Celsius along the fracture. Gas emissions from vents at both volcanoes surged by over 300%, now rich in sulfur compounds associated with deep magmatic sources. Then, Vesuvius stirred. For the first time in more than 80 years, Deep tremors were detected beneath the volcano, not shallow rock settling. Deep seismic movement, exactly the type associated with pressure accumulating in a magma reservoir. The idea that Campi Flegrei and Vesuvius might be connected is not new. Seismic tomography has long suggested a deep magma layer beneath the Campanian volcanic arc, stretching 8 to 10 kilometers below the surface. In ancient times, these volcanoes may have shared pressure and material through interconnected systems. Ash layers from past eruptions hint at synchronized activity across the region. But over thousands of years, those connections cooled and sealed. The volcanoes became isolated threats, until now. The March 2025 rupture appears to have reopened at least one of those ancient pathways. Campi Flegrei and Vesuvius are no longer behaving as independent systems. They are interacting. The Naples metropolitan region is home to more than 3 million people. Existing emergency plans were designed to handle an eruption from one volcano at a time. A dual system crisis overwhelms those plans instantly. Evacuation routes are limited. Traffic congestion would be immediate. Communication networks would strain. Emergency services would be stretched beyond capacity, and the consequences would not stop at Italy's borders. A major eruption could blanket southern Europe in ash, grounding flights, disrupting trade, and triggering respiratory emergencies. Agricultural regions could be buried, threatening food supply chains across the continent. Some scientists fear this may not be the end of it. The Mediterranean hosts multiple active volcanic systems, many suspected to share deep geological connections. If pressure changes propagate outward, they could destabilize other volcanoes from Etna to Santorini. Dr. Marco De Vito of the Vesuvius Observatory summarized the situation bluntly. We are dealing with a new class of volcanic risk. The interaction between Campi Flegrei and Vesuvius has the potential to affect millions and permanently alter southern Italy. Behind the scenes, alert levels have been raised. Emergency planners are working non-stop. But even as preparations accelerate, the ground continues to deform. New vents open, roads crack, buildings shift. The question is no longer whether something significant is happening beneath Naples. It is whether authorities can act faster than the geology unfolding below their feet. The volcanic systems of the Mediterranean are stirring. Connections buried for millennia are reactivating, and the outcome will be felt far beyond the caldera itself.